Have you ever tried to imagine a world with absolutely no math? Think about it for a moment. You wouldn't know what time it is, clock schedules. You couldn't buy anything at the store, because prices and money require counting. You wouldn't even know how old you are. It would be a very confusing, disorganized place. How would you build a house without measuring the walls? How would you bake a cake without knowing how much flour to add? Without math, the very structure of our daily lives, from our phones to our homes, would simply fall apart. It's the invisible language that holds our world together. This might sound like a strange, far-off fantasy world, but for the earliest humans, it was reality. There were no calendars, no rulers, and definitely no calculators. Life was about survival, finding food, seeking shelter, and staying safe from predators. But even in this simple existence, the seeds of mathematics were beginning to sprout. The human brain is an amazing problem-solving machine, and it quickly realized that it needed a way to keep track of things. How many people are in our tribe? How many days until the next full moon? How many berries did we gather? These were the first math problems that our ancestors faced, long before anyone had ever heard of algebra. Imagine trying to share food with your family without being able to count. You could try to give everyone a piece, but how would you know if it was fair? How would you know if you had enough for tomorrow? The need to quantify, to answer the question how much, or how many, became incredibly important. It was a fundamental step in human development, moving from simple instinct to organized thought. This wasn't math for a grade, it was math for survival. It was the beginning of a magnificent journey, an adventure of the mind that would eventually allow us to build pyramids, fly to the moon, and create the amazing technology we use every single day. Making notches on a bone was a great start, but it has its limits. Imagine trying to carve 1,000,000 notches. As societies grew larger and more complex, people needed a more efficient way to write down bigger numbers. This is where ancient civilizations like the Sumerians in Mesopotamia, around 4000 BCE, made a giant leap. They developed a system of writing called cuneiform, using wedge-shaped marks on clay tablets. For the first time, they created specific symbols for numbers. A small cone shape might mean 1, a small sphere might mean 10, and a large cone could mean 60. This was incredible. Now, instead of making 60 individual marks, you could just write one symbol. This made bookkeeping for trade, farming, and taxes so much easier. These clay tablets are some of the oldest historical records we have, and many of them are just ancient spreadsheets. They record things like how much grain was in a warehouse, how many cattle a person owned, or how much silver was paid to a worker. It might not sound as exciting as a king's epic poem, but these mathematical records tell us so much about how everyday life was organized. They were the accountants and data scientists of their day, using math to run their entire civilization. Meanwhile, over in ancient Egypt, a different system was taking shape around 3000 BCE. The Egyptians developed a hieroglyphic system for their numbers. They used a simple vertical stroke for 1, a heel bone for 10, a coil of rope for 100, a lotus for 1000, a bent finger for 10,000, a tadpole for 100,000, and a god with upraised arms for 1,000,000. With the power to write down and calculate numbers, ancient civilizations could start to build amazing things. Just look at the Great Pyramids of Giza in Egypt. These are not just giant piles of stone, they are masterpieces of geometric precision. To build them, the Egyptians needed a deep understanding of geometry. They had to be able to create perfect right angles to make the square base. They needed to calculate the precise slope of the sides so that they would all meet at a single point at the top. All of this was done without computers or modern surveying equipment. They used ropes, plumb bobs, a whole lot of practical math. The Nile River would flood every year. Surveyors, called rope stretchers, would have to go out and redraw the boundaries of the farms. To do this fairly, they needed geometry to calculate the area of different shapes of land. Rectangles, triangles, trapezoids. The very word geometry comes from the Greek words geo, meaning earth, and metron, meaning measure. That's what they were doing. Speaking of the Greeks, they took mathematics to a whole new level. While the Egyptians were practical, the Greeks, like Pythagoras and Euclid, became fascinated with math for its own sake. Pythagoras is famously credited with the theorem about right-angled triangles. A squared plus b squared equals c squared. Euclid wrote elements, organizing geometry into a single logical system and popularizing mathematical proof. They studied prime numbers, ratios, geometric solids, seeking universal truths. It was a whole new way of thinking. Our mathematical journey doesn't stop in Greece. Some of the most important contributions came from India and the Arab world. Think about the number 0. It seems simple, but it's profoundly powerful. Ancient civilizations had ways to show an empty space, but 6th century Indian mathematicians treated 0 as a number in its own right. You could add it, subtract it, multiply with it. This invention was revolutionary. It made calculation so much easier and paved the way for the decimal place value system. 1, 10, 100. This brilliant Indian system, including 0 and the numerals 09, was adopted and spread by Arab and Persian scholars, like Al-Khwarizmi. That's where we get the word algorithm. He combined Greek geometry with Indian calculation and developed solving by balancing, algebra. Ideas traveled along the Silk Road and eventually sparked the Renaissance and the scientific revolution. Today, you are surrounded by the legacy of this incredible journey. That smartphone in your pocket? It works because of mind-boggling algorithms and binary code. The GPS that tells you how to get to your friend's house. Geometry, algebra. When you watch an animated movie, you're seeing the results of millions of geometric calculations. Every photo you take, every song you stream, every video game you play. It's the invisible engine of our modern world. They are more than just symbols on a page. They are the result of thousands of years of human curiosity and ingenuity. They represent our species' incredible ability to find order in chaos and to build a complex, interconnected world from the simplest of questions. Our journey into the world of math begins not in a classroom, but in the ancient plains and caves where our ancestors first looked at their hands and realized they had a built-in counting tool. That's where our story really gets started. Consider this. Let's travel way, way back in time, maybe 30,000 years ago. Early humans didn't have paper or pencils. So, how did they count? Well, they used what they had. The most obvious tool was right at the end of their arms, fingers, toes. This is why so many counting systems around the world are based on the number 10. It's a natural, built-in abacus. You can see it in our language today when we talk about digits. One hunter could tell another, "I saw a herd of deer this big," and hold up 5 fingers. But what happens when you need to count more than 10 deer, or track more than 10 days? You'd run out of fingers. So, early humans got creative. They started using external objects to represent numbers. Pebbles for sheep, knots in a rope for days. Information could be stored and saved. The pile of stones did the remembering for you, like the world's first hard drive.